thanks. Great to be here. Thanks for having me. I'm David Kaplan. I'm actually the Vice President of Technology and Products in the legal department at Micron, and I'm here to talk about R&D. I've been in the semiconductor industry for nearly 35 years now, and I can definitively tell you that there has never been a more exciting time to be part of the semiconductor industry than right now. And there's never been a more exciting place to be than right here in Idaho. Because right here in Idaho, in our own backyard, in Boise, Idaho, Micron will be building a manufacturing facility that is like no other facility that has ever been built. This facility will be, in many ways, it will be the most technologically advanced facility that the world has ever seen. Okay, so we call it a fab. It's short for fabrication facility, and it's where we fabricate our semiconductor chips. Micron, you may have read the press releases on this. Micron will be investing $15 billion into this fab. The fab will be 600,000 square feet. So let me put that into context. 600,000 square feet. That is 10 football fields. You'll be able to put 10 football fields inside this building. And I'm not talking about office space here. Actually, most of the offices are going to be in a different building. This is mostly the manufacturing floor. And the ceiling of this manufacturing floor, these 10 football fields, will be nearly 3 stories high in order to fit the equipment in there that we'll be installing in order to manufacture our chips. So you got 10 football fields, 3 stories high, all to manufacture a product that's no bigger than your fingernail. Now, I know what you're thinking. You're thinking, oh yeah, all right, I've seen those videos, the big giant factories. They got the rows of tables and the benches and hundreds of people sitting around. They're picking and placing electronic bits and pieces and soldering them to some board. Yeah. Like that. It's like that scene of all those people sitting in the factory looking for the golden ticket in Willy Wonka that the rich dude paid for. It's nothing like that. We'll be hiring a couple thousand people to operate this facility. And that's actually going to generate an additional 17,000 jobs in Idaho, which is awesome. But they don't actually get to go anywhere near the chips. We have to keep this massive 10 football field facility immaculately clean. Just the grease from someone's fingertip or a speck of dust or even a bacteria, a single bacteria can contaminate and destroy a semiconductor chip. That's how fragile these things are. If someone's out in the fab, they've got a runny nose and they sneeze on the chips, that event will cause millions of dollars in losses. So only the robots get to go anywhere near the actual chips, not only because robots don't have noses yet, but because they need to be able to operate in a vacuum in the dark, because air and even light itself can destroy an unprotected semiconductor chip. Pretty crazy, right? But it gets even crazier. There is the equipment that we'll be installing in this fab. Now, in the interest of time, I'm just going to describe to you just one piece of the thousands of pieces of equipment that we'll be installing in this fab. This piece of equipment is called an EUV scanner. EUV stands for extreme ultraviolet. And we use these machines because EUV scanners produce a special type of light that we need in order to create our chips. Because normal light, it's too thick to print the fine detail of our circuits. Yeah, at the atomic level, normal light is now too thick for us. The wavelengths are too wide. We've outgrown it. We're smaller than light. We need photons with smaller wavelengths. And these are photons that don't even exist on this planet. They don't exist in nature. We have to create them. So you might be thinking, okay, well, these machines, they print these tiny circuits on these tiny chips. Well, these machines must be pretty tiny. No, these machines are massive. In fact, these machines, these particular machines, are one of the reasons why the ceiling in this 10 football field fab needs to be so high. Each one of these machines weighs over 200 tons and is the size of a small apartment. To get just one of these machines, just one of them, to Boise, it's going to take 3 747 jumbo cargo jets, 40 freight containers, and 20 trucks. This machine has over 100,000 parts sourced from over 8,000 different suppliers. So what's going on in this machine? Well, check it out. Inside this machine, there's a vacuum chamber. And attached to this vacuum chamber is this tiny gun that shoots a microscopic bullet made of tin into the chamber. And when this tin bullet, which is a fraction of the diameter of a human hair, when this tin bullet reaches the center of this chamber, a massive laser beam, powerful enough to cut steel, shoots that tin bullet, vaporizing it into a plasma that burns 40 times hotter than the surface of the sun. And when this happens, it releases this extreme ultraviolet light. And this whole sequence of events repeats itself thousands of times per second. Oh, yeah. And we then use that extreme ultraviolet light that's generated by this explosion to print our circuits onto our chips. And using this process, we will be able to create circuits that are smaller than the width of a strand of DNA molecules. Smaller than the width of a strand of a DNA molecule. And that, my friends, is what's happening in Idaho. Okay, so let's talk about research and development. That's why I'm here. That piece of equipment that I just described, that piece of equipment is the result of 35 years and hundreds of billions of dollars of R&D invested by dozens of companies and government labs, Lawrence Livermore in California and Sandia Labs in New Mexico. I'm gonna digress just quickly here because Jason just mentioned it, and I'm gonna build on that because it's interesting. You may have seen a month ago a press release from Lawrence Livermore Labs. They announced that they had the first ever controlled fusion reaction, and they did it by shooting a microscopic ampule filled with isotopes of hydrogen into a vacuum chamber, shooting a laser at it to vaporize it to form a plasma that burns hotter than the sun. And if that sounds familiar, it's because Lawrence Livermore Labs actually designed that system into our EUV scanners. They have the most powerful lasers in the world. So in some respects, we're going to have little fusion reactors in our fabs. This is like Steven Spielberg science fiction stuff, but it's real. Anyway, without that kind of massive R&D investment, we would be technologically stuck, stagnant. Without these kinds of R&D investments, future generations will be watching their cute little cat videos on TikTok using cell phones that are about the same size and computing power as the cell phones we use today. We'd be stuck here. Now, I love cute cat videos, but like most of us, I'd like to see our technology continue to progress and maybe even used to help solve some of the world's problems like war and famine and cancer. And R&D is the fuel that will drive solutions to those problems. Now, this might surprise some of you. After oil at number 1 and airplanes at number 2, the third largest export from the United States is semiconductors. And the US, fortunately, currently has the largest share of the global semiconductor design market. We have nearly 50% of the worldwide market share. And that is more than twice the market share as the next country, which is Korea, at about 20%. And that is more than twice as much as the next country, which is Japan, at less than 10%. So how has the US been able to maintain this position in semiconductors? Is it because we invented semiconductors? Well, we invented a lot of stuff, as Jason mentioned. We created a lot of markets. But these are markets that, unfortunately, we no longer dominate. Digital imaging, which was born out of our space program, Jet Propulsion Labs in California. If you're into technology history, I encourage you to read about the development of digital imaging out of the Jet Propulsion Lab. It's an amazing story. Televisions, personal computers, solar technology, LED, the list goes on and on. Jason mentioned a bunch of them too. They were all invented in the United States, but those markets are now dominated by other countries. So what's different about semiconductors? Well, given that I'm here to talk about the importance of R&D, you can probably tell where this is headed. One might suggest that the difference here is that US semiconductor companies reinvest a greater percentage of their revenues back into R&D than the semiconductor companies of any other country. In fact, the amount that US semiconductor companies invest in R&D as a percentage of our sales, it's not only more than any other country, it's more than any other industry. And one might further argue that it's imperative that this virtuous cycle of semiconductor investment and semiconductor sales continue. I don't want to be overly dramatic, but our future, our health, our welfare, our defense, it's all being built on the foundation of semiconductors. AI and machine learning, telecommunications and DNA sequencing, edge computing, IoT, it's all built on semiconductor technology, on Micron technology. And that foundation right now is uniquely US based, and it needs to stay that way, and it needs to be protected. It's not just a matter of national pride, it's a matter of national security, and we can't surrender that. Okay. I don't have much time left. I want to switch gears very quickly, just a little bit, and talk briefly about the importance of patents to protect R&D investments. So Micron, yes, we invest a massive amount of money in R&D, and we are fortunate enough to have a world-class, world-renowned patent team to ensure that these technologies that are being developed by our brilliant engineers and our brilliant scientists are captured in our patent applications. Micron's not only a technology leader, we are a patent leader. But that's a subject for another discussion. For now, I just want to direct you to an awesome video that shows our journey, Micron's journey to 50,000 patents. Thanks to everyone for inviting me to this awesome event, and go Idaho.